Good afternoon, everyone. I am Nishu Sharma, lecturer in Department of Mechanical Engineering of IIMT College of Polytechnic. Today, we will discuss the inversion of single slider crank mechanism. Firstly, we discuss about the what is mechanism. That is, when a one-off link of a kinematic chain is fixed, the chain is known as mechanism. It may be used for transmitting or transforming motion, or we can say that when the one of the link of a kinematic chain is fixed, that it is called mechanism. The basic difference is the chain and mechanism is that in a chain there is no link is fixed, but in a mechanism there is a one link is a fixed. And we know that what is kinematic chain. Kinematic chain is that when the one link is connected to the last link, or when the first link is connected to the last link, then it is form a closed diagram and it is called a chain. And this when this chain and when the one link is fixed in a kinematic chain, that is called a mechanism. And the relative motion between the various part of machine is a completely constrained or successfully constrained motion, and this mechanism is used for transmitting or transforming motion. Okay. Now, a mechanism with four links is known as simple mechanism, and mechanism with more than four links is known as compound mechanism. And mechanism is operate is minimum, there is the number of links is four, and then when the number of links is four, that is called simple mechanism. That then the mechanism is required to transmit power or to do some particular type of work. It is then become a machine, and the machine we see that in a many type of a machine in which they use the required transmit power to earn to some particular type of work. And the fan is like as a machine, it require uh, power and to do some particular type of a work. And in our daily life we use many type of a machine in our daily life also. In such cases, the various links or elements have to be designed to withstand the force, both static and kinetic, safely. It means the static force is that when the machine is in a stationary, and that is there is no motion occurs, that is called a static. And in a kinetic, it means when there is a motion between a various part of a machine, that is it is called a kinetic condition. Okay. Now, a little consideration will show that a mechanism may be regarded as a machine in which each part is reduced to the simplest form to transmit the required motion. Now, we will discuss the inversion. Okay, and knowing the inversion, firstly we know the mechanism. So, in the inversion, when one of the link is a fixed in a kinematic chain, it is called the mechanism, which I have discussed a bit previous. And in an inversion, we can obtain as many mechanisms as the number of links in a kinematic chain by fixing in turn different links in a kinematic chain. Okay, it means we can say that many mechanism is obtained is called the inversion, and we can say that mechanism is also a one time of a inversion. Okay, this method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversion of the mechanism. Now, we will discuss the what is type of kinematic chain. There are basically three types of kinematic chain. First one is the four-bar chain or quadratic cycle chain. Second one is the single slider crank chain, and third one is the double slider crank chain. In both types of chain, there are four links are used. Okay. In a four-bar chain, it means there are four links are connected and it made a four turning pair. Okay, because and the bow all the links have a relative motion is turning motion and form the turning pair. Now, And the second chain is the single slider crank chain. Single slider crank chain, it means it is just a modification of a four-bar chain in which a one turning pair is changes into a sliding pair. So there is a because there is a slider is used, then it is called a single slider crank chain. And third is the double slider crank chain. And in a double slider crank chain, there is a two turning pair is changes into a two sliding pair, and another is the two turning pair. Is also okay. So it is a type of a kinematic chain. Now we will discuss the single slider crank chain and the inversion of a single slider crank chain. First one is the single-sided crank chain is just a modification of basic four-bar chain. It consists of one sliding pair and three turning pair. It is usually found in reciprocating steam engine mechanism. Okay. Now in this diagram we see that it is a single slider crank chain mechanism, because in this mechanism we see that a one link one is fixed. So then it is called a mechanism. But when the link no link is fixed, then it is called a kinematic chain, that is the single slider chain. Okay, so in this link, we see that in which are four links are used. The first one is the frame, which is a fixed link. Dash, dash, dash shows that it is a fixed link. So first link is the frame, that is the link one, and we know that in a mechanism and in a machine, all the fixed link is considered as a single link. Okay, and second link is the crank, and third link is the connecting rod, and fourth link is the crosshead, okay, which guides in the piston cylinder arrangement. Okay, so now frame is the fixed, so there is a no motion, and now the link two is the which is the crank, and there is the relative motion between a frame to the crank, that is the crank is rotated about the fixed center of frame, and then when the crank is rotated, then the link 3, that is the connecting rod, it also oscillate about the pivoted point, and when the connecting rod is oscillated, then the crosshead is reciprocate, and then the piston is reciprocate in the cylinder. So we can say that in the slider crank mechanism, rotary motion of crank is converted into the reciprocating motion of piston, or we can say that reciprocating motion is converted into the rotary motion, and vice versa also. And we see that in this glider tank mechanism, there are four pairs are used. And firstly, we know that what is the pair, that is kinematic pair. A pair is the when the two links are connected, then it is only called a pair. But this pair is called a kinematic when the two pairs are connected in such a way that they have a relative motion between a various part of a machine is in a specified direction, or we can say that in a one direction, or that motion is called the completely constrained motion or successfully constrained motion. Okay, so now in this diagram, we see that there is a link 1, that is the frame, and link 2, that is the crank is connected. Then it is formed a pair 1 2, and there is the frame crank is rotated about the frame, uh, so it form a turning pair, because crank is turning about the frame, so then it is form a turning pair is there when the two links have a relative motion is turning motion, then it form a turning pair. So 1 2 pair is a turning pair, then 2 and 3, that is the crank, link 2 is the crank, and link 3 is the connecting rule is already connected. So it also have a turning motion, and it forms a turning pair. It means 2 3 is also a turning pair, and 3 4, that is the connecting rod, and the crosshead, it is also have a turning motion, that it is have a turning pair. It produces a turning pair. So 3 4 is a turning pair, but last pair is the 1 4. That is, one is the fixed link and the fourth is the crosshead. And it means that crosshead is reciprocate about the frame, that is the link 1, that it form a sliding pair because it have a sliding motion. When it have a sliding motion, it forms a sliding pair. So in this diagram, we see that we have a four pair, that is the 1 2, which is a turning pair, 2 3, which is also a turning pair, 3 4, it is also a turning pair, and 1 4, it is have a sliding motion, so it is a sliding pair. But in a 4-1 mechanism, all have a turning motion, so all the pair is a turning pair. Now we will discuss the inversion of single slider crank mechanism. So in the inversion, we see that there are the four links, that is frame, crank, connecting rod and guide. So in an inversion, we see that in the first inversion, we see that frame is fixed. In a second inversion, crank is fixed, and the third inversion, connecting rod is fixed, and the fourth is crosshead is fixed. It means that different links is formed a different inversion. Now we discuss the inversion of a single slider crank mechanism, that is the pendulum pump or bull engine, which is the first inversion of a single slider crank mechanism. In this diagram, we see that there are four links. First link is the piston rod, that is link 1. Second is the crank, that is link 2. Third is the connecting rod, that is the link 3. And the fourth is the cylinder, that is the link 4. It means in this diagram, link 4, that is the cylinder is fixed. So that is the one type of an inversion is formed, and this type of inversion is called the pendulum pump. Okay. So in this mechanism, rotary motion of crank is converted into the reciprocating motion of piston rod. When the crank is rotated about the fixed center, when the crank that is linked to is rotated about the fixed center, then the connecting rod which is connected to the piston rod, the crank and piston rod, which is oscillate about the pivoted point, and when the connecting rod is oscillated, then the piston rod, that is the link one, is reciprocate into the cylinder. This is the working of the this mechanism, that is the pendulum pump. And in this mechanism is fixing the cylinder, and it is forms a sliding pair. And this mechanism is used to supply feed water to boilers have two pistons attached to a link pin, because in this case we see that there are two cylinders are used, so it is used for the supply feed water to boilers have two pistons attached to a link pin. It is all about the first inversion of single slider crank mechanism, that is pendulum pump or bull engine. Now we will discuss the second inversion of single slider crank mechanism, that is oscillating cylinder engine. We see that in this inversion, the connecting rod is fixed, and in a primary inversion, the first inversion is, that is the bull engine, that is there is a cylinder is fixed. But in this, we see that connecting rod is fixed, that is the link 3, and it also have, we see that it have also a four links. First one is the piston rod, second is the crank, and third one is the connecting rod. Fourth is the cylinder, that is the link 4. Okay, so same mechanism is like that. First motion is started with the crank with the fixed center. When the crank is rotated about the fixed center, then the piston rod is a reciprocate in a piston rod is reciprocate in a piston, that the cylinder is oscillate about the pivoted point. Okay, so in this mechanism, we see that it is used to convert reciprocating motion into a rotary motion. Okay, or in this mechanism, we fix the connecting rod, so we can say that in this mechanism we fix the turning pair. Okay, and this mechanism is used nowadays in a toys and machines. and primarily it is used in a engines also, but nowadays it is used in a toys. Now is the third inversion, that is the rotary internal combustion engine or genome engine. Okay, and we see that in this mechanism the fixed link is the crank. Firstly, we know that in an inversion that it is a very important thing, what link is fixed. Okay, so in this inversion, that is the rotary internal combustion engine or genome engine, there is a fixed link is the crank, and we see that is the fixed crank, that is the link 2. So when the crank is fixed, then the motion is started with the connecting rod. This also called as the driving crank, that is the link 4, and link 3 is the piston, link 1 is the cylinder. So when the connecting rod is rotated about the fixed center, then the piston is reciprocate, and when the reciprocation of the piston, cylinder oscillate about the pivoted point. And this engine is used for using aviation, aircraft, and nowadays it is used in a gas turbine also, and it is in a general condition and the necessary condition for the rotary internal combustion engine is there is the odd number of cylinder is used in a one plane, and all revolves about the fixed center D. And in this diagram, we see that there are seven cylinders are used in one plane, and which is fixed center D, and while the crank link to is fixed. Okay, so in this case, we also see that turning pair is fixed. Okay, now is the we discuss about the fourth inversion, which is very important, and we see in the mechanism machines, that is shaper machines, that is the crank is routed lever quick return motion mechanism, and last one is the Whitworth quick return motion mechanism. They are almost same, but difference is that the name of the fixed link. In a crank is slotted lever quick return motion mechanism, the fixed link is the connecting rod, and then the Whitworth quick return motion mechanism, the fixed link is the crank. Okay, so in the diagram we see that there are also a four link because it is an inversion of a single slider crank mechanism. First one is the fixed link 3, that is the connecting rod, and it forms a turning pair, and second link is the crank, that is the CB, this is the link 2, and first link is the slider, that is the link 1, which is pointed on the point B, and the fourth link is the slotted bar, that is the link 4. Okay, and the mechanism is also started in a crank, and the crank is firstly crank is rotated about with a fixed center C, and through the rotation of the crank, slider is which is placed in a slotted bar, it is reciprocate, and due to the reciprocation of the slider slotted bar, AP is oscillate about the pivoted point A, and this the motion of the slotted bar is transferred to the ram through the connecting rod, and in a ram it is which a tool is used, and when the tool is moved in forward direction, then we have a cutting stroke and the material is cut, so it is also known as the forward stroke, cutting stroke, or working stroke, because material is cut in this stroke. Okay, when the tool move in backward direction, that is also called return stroke. In this stroke, the no material is cut, so it is also known as return stroke, backward stroke, and ideal stroke. Okay, and this mechanism is mostly used in shaping machine, slotting machine, and in rotary internal combustion engine. And we see that when the crank is moved from the CV1 to CB2. CV1 and CB2 is nothing, it is just a crank position. And when the crank is moved from the CV1 to CV2, then form the cut tool is moved in a forward direction and form the cutting stroke and makes the angle beta. And when the crank is moved in CB2 to CB1 in a clockwise direction, and in a cutting stroke also crank is rotated in clockwise direction. When so with crank cutting stroke is occur when the crank is moved CB1 to CB2 in a clockwise direction and makes an angle beta. And when the crank moves to CB2 to CB1 in a clockwise direction and makes an angle alpha to be formed a return stroke. Okay, and we see that the beta is greater than alpha because we know that the time of cutting stroke is always greater than time of return stroke, because in a cutting stroke the material is cut and in the extreme position of AP, that is the slotted bar, that is AP1 and AP2, which is tangential to the crank circle. Okay, so we can say that the time of cutting stock to the time of return stock, that is the in a cutting stock we generate angle beta, in a return stock we generate angle alpha. That is the we know that alpha plus beta, the rotation of crank is all for 360 degree. So alpha plus beta is equal to 360. So we can say that beta upon 360 minus beta or 360 minus alpha is equal alpha. This is all about the crank and slotted lever quick return motion mechanism, and also with that the length of the stroke, that is R1 R2, and we prove the derivation. It is also equal to the 2 AP into CB upon AC. Now is the last inversion, that is the Whitworth quick return motion mechanism. In this mechanism, we see that the fixed link is the crank, that is the link 2, and the driving crank is called the connecting rod. Okay, so in this case, the connecting rod, when the connecting rod is rotated about the fixed center, that the slider is moved along the slotted bar, and the slotted bar is oscillated about the pivoted point D, and the motion of the slotted bar is transferred to the ram through a connecting rod, and then the ram cutting tool is generated. It is same as the Whitworth quick return motion mechanism, but difference is that in this case, the when the crank is moved to CA1 to CA2, or we can say that BP2 to BP1 and a clockwise direction makes an angle alpha and generate a cutting stroke. And in when the crank is moved to CA2 to CA1 in clockwise direction, we move by angle beta in a return stroke. And we know that the time taken in forward stroke is more than the time taken during the return stroke. So we can say that the mean speed of the ram during the cutting stroke is less than the mean speed during the return stroke. So ratio between the time taken during the cutting and return stroke is given by the in a cutting stroke we generate angle alpha, and return stroke is given beta, and same alpha plus beta is the 360. So we can say that this, and then in this case the length of effective stroke, that is R1 R2, is equal to the PR, and which is also equal to the 2PT 2PD. So it is all about the inversion of a single slider crank mechanism. So thank you.